Welcome to myprojectbazaar.com. Let's discuss about the product. Our product is consistency analysis of oriented features for fast and accurate palm print identification. A typical palm print identification system identifies a query palm print by matching it with the template in the database and comparing the similarity score with a predefined threshold. However, continual database expansion would make conventional brute force search method inefficient for large-scale palm print identification. In this paper, we propose a consistency-oriented feature, that is COP. This is the hashing method to enforce fast search. Using the orientation and response feature extracted by steerable filter, we first give an analysis on the consistency features. Because the COP is very stable across the samples of the same subject, the COP hashing method can find the target template quickly and thus can lead to early termination of the searching process. Experiments have been carried out on several real and synthetic databases, and the result shows that the COP hashing method can accelerate the identification process by more than an order of magnitude and can achieve comparable identification accuracy while compared with the state-of-art approaches. Palm print recognition, a relatively novel but promising biometric technology, has received considerable research interests in the last decades. After more than 10 years algorithm and system development, a number of palm print recognition based biometric systems have been successfully applied for real-world access control applications. A palm print identification system typically involves a number of templates of registered subjects and a predefined similarity threshold. When a query comes, but brute force search based system usually matches the query with the templates only by one until it finds the target template whose similarity score is higher than the threshold. One query more by correctly identified or wrongly identified as other subject or no match is found if all the similarity scores are lower than the threshold. By far, a number of palm print recognition approaches have been proposed in the literature. Among them, coding-based methods are most promising ones because of their small feature size, fast matching speed, and high accuracy. In the feature extraction stage, these methods encode a response of a bank of filters into bitwise code, and in the matching stage, the similarity score can be efficiently computed by Boolean operators. Despite the fast matching speed of coding-based methods, when applied on a large-scale identification system, it is often necessary to speed up the searching process. Although several strategies have been proposed for the fast palm print identification, these methods, however, either lead to much accuracy less or only obtain limited speedups. Let's see the design system. So the black diagram represents of our flow and design system of our proposed system. Here, as a database, we are using palm prints. So in our process, we are using number of palm prints in the folder of database, so which is used for the whole process. Initially, we are giving an query palm print. So the query palm prints is processing using MATLAB processing. So for that, initially the given input palm print is pre-processed. In the pre-processing stage, noise removal is performed. For noise removal, we are using filterings. So and then the translation and rotations are performed for the filtered palm print, and then the feature extraction methods are applied. The feature extraction methods are based on convolution kernel and COP methods. Actually, COP method is a hashing process. So as from the result of hashing, we are getting a values, that means image. So yeah, that image has a particular value in the backend. That value is called future values, and that values is used for the classification and identification. Let's see the demonstration of our product. As we already discussed, our product is developed based on MATLAB programming. For that we are using MATLAB programming tool. So this is the MATLAB 2008 version. So this is all our functions used for our process. So this is the main window of MATLAB. So the directory which you have located will show what are the files available in the directory. All the files are used for our process. So depend on the selected process, you can get the details here. So the workspace denotes the values available for the MATLAB functions. So for the temporary values will be loaded here and you can display them. So this is the command window. So let's come to the process. So these all are the program files. .m files denotes the programming files. That means MATLAB programming. So you can see there are similar name pom_main.m and pom_main.figure. So this is the guide design file and this is the programming file. While you are running the programming file, it will redirect the figure file. The figure file consists of guide design. So I am right clicking and selecting run. Instead of, you can press F9 for run the program. So I have selected the run program. So these are the main window of our process. So initially I am going to select the input image. So it will redirect to some folder which you contains that folder. So I have selected an image. The selected image will be displayed here. After that, as we already discussed, I am going to do pre-processing. In pre-processing, the noise is removed. So for noise removal, we are using filtering methods, and then ROI extraction is performed. So the ROI extraction is performed for the only focused area, and then image enhancement. It will make the image visibly and it will give visible expansion. And then as our process, we are applying steerable filter. So the steerable filter is applied and the steerable filter response is obtained here. And then COP, that is oriented patterns. So you can see what are the COP performs here. So this is the COP. That points are used for a future person, and then the points which is compared with the database, and depend on the matching, the query points is matching with the person 4. So followed by that, results are performed here. This is the performance result: fault acceptance ratio, average identification time, GAR, and then fault rejections ratio. The comparison between previous methods also performed here. Thank you.